Hello, everybody. Very welcome to Giza Western Cape's talk this morning, or this afternoon at least. And it gives me great pleasure to be your host for today. Before I hand you over to our speaker for today, I basically just wanted to quickly update people while we still wait on a few more people coming into the meeting onto the latest Giza activities. And I just want to confirm that on the 15th of March, we had our biannual committee election. A new committee was elected for the Western Cape, and our new chairman is Van Heerden Fourie. Our vice chair is Karel van der Merwe, and our secretary is Justin from Mediquip. So I just want to welcome the new members and also the new board members to the Giza Western Cape branch. Giza Western Cape also had a week ago a very nice walk up Lion's Head next to Table Mountain. It was really awesome. We only had a few candidates, but we hope to repeat something similar in the near future. And then another highlight that we are looking forward to for this year is to perhaps do our annual lecture event, previously known as the Giza Breakfast, in person. So watch the space and let's hope for the best. I think the time is ripe to introduce our speaker, Mr. Danny Wang. Danny is talking to us all the way from China. And I can tell you that between 2011 and 2015, Danny got his bachelor's degree in physical engineering. And between 2016 and 2018, he got his master's degree of nanotechnology. That seriously sounds so interesting. And then in 2018, between 2018 and 2020, then Danny became the technical support engineer for Europe and the African region. And then between 2020 and 22, he became the marketing for Southern Africa. And Danny, I hand over to you, and we can't wait to hear your talk on ICU monitoring. Thank you very much.
Thank you, Curtis. Hello, everyone. Let me first share my screen. I just want to make sure you can see my presentation, right?
We can. Thank you, Danny.
Okay, then I will start. So firstly, this is my first time to doing the webinar for the Giza. So it's really glad for me, and it's really honor for me. So today my topic is for the advanced IT solutions for the ICU, OR, and emergencies. So as we know, the ICU, OR, and the ER is the three most important departments in the hospital. So that's why I chose these three departments. And also nowadays, even for the modern hospitals, we have a lot of challenges in ICU, OR, and the ER department. So some of these challenges we can solve by advanced IT solutions. So, which is also the topic I would like to introduce today, is we call it the M-Connect IT solutions. So basically, M-Connect is a platform based on the scalable and flexible IT solutions. So it can connect the patient, healthy providers, medical devices, and also healthy care information systems. From this left graph, you can see it can divide it into three different levels. The first basic level is bedside device connectivities to connect all the bedside devices, such like the ventilators, monitors, pumps, to patient monitors, to let the patient monitor as bedside information centers. Then for the second level, we connect the patient monitor to the central stations, central station network systems. So we have a lot of central stations, workstations, wheel stations, different software and systems I will introduce later for the detail. And then the third level is to connect the department information to the whole hospital information systems. So via the e-gateway systems, we can upload, not only upload, bi-direction communication, the central station information with hospital information systems. This is a general system of the M connection platform. So then following, I will introduce how we apply these solutions into different departments and to solve the challenges now facing. The first department I choose is the ICU department. So ICU is one of the most important scenario in hospital, and it is also the last granting for the very critical ill patient. So, but unfortunately, even nowadays, the mortality in ICU is also very high. So some research also shows that the deterioration symposium could be found earlier and can avoid some of the sudden deterioration deaths if the caregivers can find out the deterioration. So there is a sentence to say there is no sudden deterioration in ICU, only the deterioration be suddenly discovered. So the challenges we face in ICU nowadays, first is the patient safety. So sometimes it will have the alarm missings or have the medication errors to cause the deterioration and the sudden deaths. And also for efficiency is also one of the biggest challenges. Even in Europe and the US, so the ICU nurse workload is very heavy. For each nurse, they may need to take care 3 to 5 beds, and especially in the night. So the workload is very heavy. The heavy workload and the complex workflow will increase they spend more time on some indirect care, such like the paperwork, etc. To in case to lead to they have less time to direct care for the patient. So in order to solve such challenges, we can following the 2 directions. First is, as I mentioned, to integrate all the device informations to the patient monitors, using the comprehensive integrations to high quality diagnosis and treatment. This is structures to integrate the bedside devices to the patient monitors. For the patient monitors, we have the plug and play band link modules. With these modules, we can connect the bedside devices in ICU, such like infusion pump and ventilators, to the patient monitors, and integrated all the informations into one screen. Here you can see in the patient monitor display, there is not only the vital signs, but also you can see there is numerical information of the ventilation parameters, and also the real-time waveforms and the real-time alarms, all shows in the patient monitor screens. This avoids the alarm missings for the patient. And moreover, with the infusion wheel functions, here in the left you can see it will shows the vital sign and also the infusion rate. So with these functions, you can see when you change the infusion rate, what influence to the patient vital signs. It's very intuitive, and it can guide the doctors for the process medications. And also all this data will be recorded into the patient monitors. So in case some problem happens, you can review these data to find out what actions or what move for what changes for the infusions cause the problems. So this is at the patient monitor side. And for the second level, we can connect the patient monitor to the department information system, the central station systems. On the central station, it's similar. So when you integrated the bedside devices, information, the parameter of the bedside devices will also shows here on the central station systems. So this will also avoid any missing of the bedside devices. You know that normally we, for now, a lot of companies, they have the central stations to connect the patient monitors, but they only connect the patient monitors. Only few of them can have the information to check for the ventilators and the pumps in the same screen and the same displays. So this band link solutions can solve this problem and integrated all the informations into the same screen. And here you can see for this BandLink modules, it can not only connect for Mindray's product, it can also support connect more than 150 mainstream devices. 80% of the mainstream devices using the ICU can use these functions to connect to the patient monitors. And also, when you have these structures, you can build a silent ICU. So here is the structures to how the silent ICU works. So in the silent ward or silent ICUs, so we're using the patient monitors to integrate all the devices to the patient monitors, and then using patient monitors connect to the department central stations. So outside of the ward. So in the ward, you can turn off the devices audio and alarms for the patient monitor and the other devices. So keep silence in the ward and to enhance the recovery. And also the caregivers is no need to enter the ward or enter the ICU very frequently. They just need to check the information on the central stations. And they can also control the central control the bedside patient monitor via the central stations to measuring the NIBP or change the alarm limit, etc. So this method avoid the unnecessary contact, so reduce the infection, especially during the COVID situations. This is very useful. And here in these photos, you can see is real photos in the hospitals in France. The Toulouse University hospitals is one of the reference hospital of us. So here I have short videos, the interview of this hospital's colleagues. So you can have the more intuitive to see how it worked. Let me share these short videos.
On est Trauma Center, donc on reçoit toute la polytraumatologie de la région Midi-Pyrénées. On a aussi la neurochirurgie, donc des patients qui sont cérébrolésés. On a des post-opératoires de chirurgie lourde et on a aussi des détresses respiratoires avec des syndromes de détresse respiratoire aiguë de l'adulte. Donc nos principaux défis pour optimiser la prise en charge de ce type particulier de patients, ça va être d'avoir un monitoring adapté à ce type de patient. Je ne vais pas vous parler, en termes de paramètres mesurés, je ne vais pas vous parler des paramètres standards qu'on retrouve dans tous les monitorings, mais plutôt de ce que nous, on a recherché dans la solution Mindray. Ce sont, alors, sachant qu'on a une population de patients polytraumatisés et cérébrolésés, ça va être le monitorage du capteur de la pression intracrânienne, le monitorage de l'électroencéphalogramme. On fait pas mal d'hémodynamique. Il y a aussi le monitorage par thermodilution, donc par picot. Donc ça fait partie un petit peu de ce qui nous a décidé dans nos choix.
Le système Bénévision a été très facile à utiliser pour nous, car c'est un système très intuitif et que nous avons été très bien accompagnés par les équipes de Mindray pour former le personnel et toute l'équipe infirmière.
Nous avons procédé à l'installation de la gamme de moniteurs N22 dans un service en activité. Nous avons demandé aux équipes Mindray de préparer au maximum le matériel à l'extérieur du service et de finaliser l'installation lorsque un box ou une chambre se libérait. Ce qui a été fait. L'installation s'est déroulée vraiment sans problème. La solution de monitorage Mindray utilise un réseau privé qui communique avec le réseau du CHU par le biais de passerelles. Ces comptes permettent de recevoir les différentes mises à jour et répondent donc à la sécurité informatique du CHU. Enfin, l'implémentation du dossier patient informatisé par les données des dispositifs médicaux externes nous permet d'éviter d'avoir à saisir ces données et donc d'éviter les erreurs de saisie.
Où le côté tactile est important dans le quotidien. Il faut vraiment qu'on soit fiable à la fois sur le monitoring, sur le côté tactile. Ce qu'on a recherché aussi dans ce type de monitoring, c'est d'avoir une connexion donc avec notre logiciel métier, puisqu'on a une disparition complète du dossier papier, on fait tout en informatique, et il fallait que vraiment on ait une interface qui soit fiable et efficace. Déjà, c'est aussi la possibilité, enfin c'est le choix qu'on a fait de mettre la working station à l'extérieur. Ça nous permet, quand on a à faire une prescription, à valider une alarme, changer nos amplitudes d'alarme, de pouvoir le faire de l'extérieur sans rentrer dans la chambre du patient. Donc ça présente un avantage non seulement pour le patient, si le patient est endormi, on ne va pas rentrer dans la chambre et le stimuler. Ça présente aussi un avantage en termes d'infection nosocomiale parce qu'on n'est pas obligé de rentrer, sortir, rentrer, sortir. On peut tout faire de l'extérieur. Ce type d'équipement s'intègre dans les nouvelles recommandations de ce qu'on appelle, nous, le mieux vivre en réanimation. Et ça, c'est quand même, pour le patient, moins de nuisances sonores, pas d'alarme, moins d'angoisse, puisqu'il ne voit pas ses paramètres. Donc, dans le mieux vivre en réanimation, dans les innovations, il y a effectivement la possibilité de faire rentrer des musiciens dans des chambres de réanimation pour qu'ils puissent écouter de la musique et que ça les sorte du contexte médical. Et dans les perspectives aussi que l'on a dans le service en termes d'innovation et qui seraient liées d'ailleurs au monitoring et à l'agencement et l'architecture de la réanimation, c'est l'utilisation des smart pagers.
Grâce aux smart pagers, on pourra fermer les portes des chambres des patients et assurer quand même leur surveillance, ce qui améliorera grandement leur sommeil et leur vécu de l'hospitalisation en réanimation.
Je crois que c'est ce qui fait toute la force de cette installation, les couloirs de la réanimation devenant des espaces de travail pluridisciplinaires et les box devenant des espaces vraiment silencieux pour une meilleure convalescence du patient.
Okay, via this short video, you can see how they built their silent ICU in France in these Toulouse University hospitals. So there is totally no any alarms in the ICU in the ward. Even the musicians can play music here and also the patient did not see any of the parameters, so they will not worry about their situations to give them more relax. To help them to recovery more faster. So this is the bedside devices integration levels. So to build the ICU structures. And then another advantage is for the department levels. At the department levels, we can use in the different central stations to assist the data anywhere and anytime to enhance the patient safeties. This is how usually central station system deployed. So firstly, we use the bedside devices using the wired or wireless network to connect the central stations. The central stations can saving the data and also to bi-direction control the patient monitors. And also, of course, it has the alarming functions. And then through the central stations, the measurement data of the patient then can distribute it to the workstation, wheel station, and also the CMS wear, and also mobile wear. You can also see in that short videos, they have the cell phones or the PDA, the smartphones, so to check the patient information on hand. And also normally we deploy the central stations in the nurse stations. So nurse can monitor the multiple patients from the different ward at the same time and manage the devices. So for some big hospitals, if there are several care groups in the same department, we can also deploy the one central station plus several workstations. So the workstation is similar to central station, but the workstation cannot save the data and also cannot manage the devices, but it can control the patient monitors to measuring the NIBP. And if the clinicians want to keep an eye on their patients in the corridor, in lobby, or in the cafe room, so they can also deploy the view stations in the meeting room, corridor, or coffee room. So to view the multiple patient information anytime. For these view stations, it also has the alarming functions. And then is the CMS viewer is used to monitoring the single patient outside the ward. For example, usually installed in the doctor's computers to let the doctors to view the certain patient information in the ward. And also the last is mobile wear. So the mobile wear is an app which can install on any smartphones and also other PDA devices using the Android systems. So it allows the doctors to monitor the patient even outside of the hospitals via the 4G network to assist the patient data. And I know in South Africa, there are a lot of hospital groups. For hospital groups, they have several different hospitals in different cities and province. So for these hospital groups, if their human resources is limited, so maybe in the sub-hospital, they not have enough doctors, experienced doctors or caregivers to monitor the patient, they may need help from the hub hospitals. For these hospital groups, the system can also achieve the remote monitoring. We can deploy the workstations for remote viewing in the hub hospitals. Then it can get the information of the patient data in the ICU in the different sub-hospitals. And this is what these structures look like. So for example, if one hospital groups have one hub hospital and two sub-hospitals in different cities, in the sub-hospitals, the department structure, as I mentioned before, is just using the patient monitor to connect to the central stations. Then the central stations can using either the hospital VPN or to get a public network IP from the hospital IT department, and then send to the public network. Then from the hub hospital, the workstations can get connect these two sub-hospitals via the wireless networks, and then it can get all the information to view here. And this structure, also called war room solutions, is for central monitoring of the patient for different hospitals or different departments. This mode is very popular nowadays in North Americans, and it can not only ensure the patient safety, but also helps reduce the labor cost. So you can, if you only have very limited experienced caregivers or the doctors, you can let them in the hub hospitals and in these war rooms to monitoring the real-time information from sub-hospital and give the guidance. And at the same time, it can also monitoring the different care groups from these hub hospitals, just as the previous structures for the one hospital structure. So this is another connectivity advantages for the hospital groups. And then the third topic is for the fault connectivities to streamline the workflow. As I mentioned before, the main challenge, except the patient safety, another one is heavy workload and also the complicated workflow for the ICU nurse and the doctors. So with devices connectivities, first we can solve the transport challenges. We can achieve the seamless transportation care. For example, if the patient need to doing the CT or need to doing other tests during the ICUs, so we can using these transport patient monitors together with the patient. So there is no need to reconnect any patient cables. So there is uninterrupted monitoring. So we just using these N1 monitors together follow the patient. And then when the patient done the test, when they back to the ICU, they just insert this transport patient monitor into the host monitors as modules. Then the data during the transport will upload automatically to this host patient monitors. If this transport patient monitor have the Wi-Fi function, then during the whole transport process, the data will real-time via the wireless network to upload to the central monitoring systems, so to achieve the seamless care for the patient. Another application we can do is for the infusion closed loop management. For the traditional infusions, it's normally like this. The doctors give the prescriptions, then the nurse gets the prescription papers and confirm the prescriptions, and then go to the chemist to dispense the different drugs. And then nurse preparing the drugs and labeling the different drugs, and then setting the infusion parameters for infusion pumps. In this whole process, it's all manually done. It has human errors during every steps, and also is very low efficiency. So with information systems, if the infusion pump, patient monitors all together connect to the hospital systems, we can achieve such kind of closed loop management. For infusion, for information check, the doctors can, the nurse can just scan the patient medicine barcode or QR code to confirm the patient, and also the drug information for this patient is for automatically. Then for the prescription, so the caregivers can start to execute the prescription distributed from the CPOE without extra manual settings. So because it's all connect to the central stations, so the doctors give the prescription in the system. Then after the nurse confirm the patient information, the prescriptions will automatically download to this pump and to execute. Then during the infusion process, the real-time data will monitor, and the medication process can be the timely response to the alarms. And then the doctors can adjust the medication plan if needed, if they check there is some needed to change the medication plan according to the real-time monitoring. And at the end, with the standard HL7 interface, the real-time medication information can automatically upload feedback to the EMR or the HIS system of the hospitals and fulfill this closed loop medication management. So with this closed loop management of the infusion compared to the traditional way, there is full automatic, and there is no steps to have the human errors. All is directly in the systems. And also it's reduced a lot of paperwork. So the nurse only need to do two things. First is scan the barcode or QR code of the patient, then scan the machines to band in the machine together, and then to confirm the prescriptions. That's all. And for the dental data synchronizations to the hospital systems, so we can using the e-gateway softwares. We know there nowadays in hospitals, there are a lot of different HIS systems. There are different suppliers, but they're all using the standard HL7 communication protocol. So with e-gateway functions, we can achieve the communication between the patient monitors, between the central station systems to your hospital systems. It can synchronize the patient information and the system time automatically, and send all the bedside devices data to this third-party information system automatically. And also, if the patient already registered in the systems, it can also synchronize to the patient monitors in the ICU. So for these dental synchronizations, it can highly improve the working efficiency. So for the traditional way, when a patient enters the hospital, first they need to registrations its registration in the hospital systems. Then when the patient come to the ward or come to the ICUs, the nurse need to manually input the patient information into the patient monitor or other devices. Sometimes they may also need to manually record informations. I think in South Africa, in the ICU, there are every bedside have a big desk with a very big paper to record the physiological data. The nurse needed to manually recording every certain times. Then when the doctors want to check the patient information and want to give the diagnosis, they need to review the patient data from the different file archive. It's very complicated. And then when this patient cured, when out of the hospital, when discharged, the hospital needed to print in a lot of report from different systems, from different departments. This is for the traditional way, without any IT connectivities for the devices. So if the hospital doing the IT connectivity from the bedside devices to patient monitor, then patient monitor to systems, then using the e-gateway to communicate to your hospital information systems, then can integrate all these informations to the systems. It's more easy. In this way, when the patient enters the hospitals, the whole process is paperless. When they enter the hospitals, they register their information in hospital systems. Then they get a barcode or QR code, just as you see in the previous video in the French hospitals. Every patient have their own barcode on their arm. So it's like their IDs in these hospitals. Then when they come to any department or come to any like ICU or doing the test, so to the bedside, the nurse just scans the QR code and of the patient, then scan the QR code of the devices to pairing this patient with these devices and this bed. Then the connect the patient monitor to this patient. The data, the patient data will automatically recording and upload to the systems. So in this situation, when the doctors want to diagnose or review the patient data, it can very easily, it can just review from one systems, from any your hospital information systems, just to open the different windows for different data. So in one systems. So when the patient discharge, it can generate the e-report, directly send to the patient email box or to the cell phones. Or if they want to print in the report, it can also print in from one systems. It's very simple. So this is how this look like. So you can see here, when the patient enters the hospital, it has a barcode, the QR code on their arms. Then when come to the bedside, it scans the barcode first. Every devices have their own barcode. And you can see here. Now the patient information already in these PDA devices, and then scan to the patient monitor, and now wait a little bit. So now you can see this is a patient name already synchronized to these patient monitors, which means this patient is pairing with these devices. So it's reduced the time for the manual input. And then after the patient pair with the devices and keep monitoring in the ICU, the doctors can check the patient information anywhere, anytime from the mobile phone or the PAD devices or on their computers. Here you can see this is devices, mobile devices in hospitals. It's for the hospital systems. It's also including a lot of systems integrated here. But from these systems, it can directly enter the patient monitor systems for this patient. You can see here is check the real-time data monitoring for this patient. And also this here is for the computer side. This is a hospital systems, then enter to the monitoring systems to review the history data. Then here is to check the real-time patient data. So this is very convenient and the system is very flexible because it's using the e-gateways. It will transfer all the patient monitor data, integrated devices data with the HL7 protocol, which is the standard protocols. So most of the supplier of the HIS support these protocols. So it's no need to further development for the systems. So it's very easy to connect. So you can see it checks the different patient in the ICU department. And with this kind of hospital information system integrations, there are research to show that it highly improves the care quality for the patient. So you can see this is a research done in several hospitals to compare the direct care and the indirect care for the nurse for each patient each day per minute. So on the top is for the direct care, for the treatment, vital sign recording, or the patient education. It's calculated as a direct care. So the gray bar shows how many minutes the nurse do this without the M-Connect solutions. The red bar here shows when the nurse using the M-Connect solutions, what is the each day, how many minutes they doing the direct care for the patient. The bottom is for indirect care, so such like the paperwork, device setting up, printing report, etc. So here from this graph, you can easily see that without the device connectivity solutions, a lot of time is wasted on the paperwork and also printing report, etc. You can see here the research shows with the M-Connect connectivity solutions, the direct care time for each patient per day increased 11 minutes. But you can see here, the total nursing working time is decreased 20.5 minutes. This means we reduce the nurse workload every day. They have less work to do, but however, they increasing the direct care time to give a better care for the patient. I think for the hospitals, they have very serious human resource problems. This is a huge improvement. So for the same human resource, for the same number of the nurse, the caregivers, they can doing more work. They can doing the better care for the patient. This is the first part for the ICU department. Then the second part I want to introduce is the applications for the device connectivities in the OR department. So the structure is similar to the ICU. If you understand this ICU part, then the next part, OR and the ER, is very simple. We're just using the different way to apply these technologies. Also, the first is the challenges in the OR department. So first is perioperative management is very difficult. Also, the scattered equipment and the limited informations to decrease the efficiency of the doctors and also the nurse. Then is patient sometimes under the very high risk. This is a challenge, 3 big challenges for OR department. And also the first step we do is to fully integrated the devices into one patient monitors. And also you can see here for the transport, for the OR transport, normally when the patient do the surgery, they first need to go into the prepare room. So if they have the barcode, so their information already registered in the hospital information systems, just scan the barcode of the patient and the devices to pair them. Then in the induction room, they can use in the N1 transport patient monitors for the patient for the whole process. There is no need to disconnect the accessories. So the whole process, the N1 is together with them. Also in the operation rooms, all the patient data saving in these transport patient monitors. You insert this transport patient monitor in any host of monitors, the data will upload to this one. In induction room, it will upload to the induction room bed. in the systems. In the operating room, when you insert the patient monitor, it will synchronize information to the operation room patient monitors. And then when the patient to the recovery room, then the data is also follow the patient together back to the recovery room. And also for the operation room, for the daily work, you can see the anesthesiologist need to face a lot of devices, like the patient monitor to check the vital sign, the anesthesia machines to check the anesthesia status, and also sometimes they need the BIS monitoring or the NMT monitoring, or sometimes they need the infusion pump to doing the anesthesia. There are too many devices and too many informations. In this situation, they may miss some important informations. With the integration technologies using one patient monitors, similar in ICU, using the band link modules to integrate the infusion pump information, anesthesia information, and also some advanced parameters, and also the hospital information systems together into one patient monitors. So during the operations, the anesthesiologist only need to watch the patient monitors, then he can get all the informations. Here is how this looks like. You can see it can enter the PAC systems in the patient monitors to check the images, or it can enter the AIM system on the patient monitors to doing the record of the doing the record for the anesthesia process. And with these solutions, it can save the space for the operation rooms. So reduce the devices and the cables, is look more clean and more nice, and also reduce the human errors. And also it can get all the patient information and data. So for one screen for all the data, improve the efficiencies and of the diagnosis and the treatment. Then the last one is it synchronizes the times for all the devices together. All the devices you can see synchronize time with network time protocols to same time for every devices. So in case there something bad happened in the surgeries, when you check the record, so every record for different devices is using the same clock. And then the second level is similar to assess the data anytime, anywhere, similar to the ICU, but we have the different applications in the OR department because the scenario is different. This is also to help to solve the human resource problem. You know that sometimes in the hospital, they only have one experienced senior anesthesiologist and rest are some junior anesthesiologists. So sometimes they need guide from the senior anesthesiologist. So, but during the surgery, they may in different surgery rooms. But if you connect all the patient monitors into the hospital network, then between different patient monitors, it can share the information and it can show another bed, bed information into one screen. So here you can see this is a screen for the senior anesthesiologist rooms. The top is the patient in his operation room. Then for the junior anesthesiologist room, for the patient there, it can also check on the patient monitors. It shows on the bottom. So it can find out the dangerous or find out problem in time and give the timely guidance. And also, if the hospital have the medical directors, he want to monitoring all the OR process, all the surgery process, it can install the central stations in his own office. So he can view all the data of the surgery patient in office via view station or central stations and taking control of the overall situations. For the senior one, as I mentioned, it can check another patient monitor in junior doctors' operation rooms. And for the junior anesthesiologist, if they meet some difficulties or challenges, it can using the call help functions. It's just one button on the patient monitors. Click on these buttons, then on the senior anesthesiologist patient monitor will give the alarms and will give the information to say that the junior anesthesiologist in which OR need the guidance or need the help, and then it switch this monitoring, bed monitoring view to this OR and check the patient information, and maybe you call the junior anesthesiologist to give the guidance, or maybe directly go to another OR to solve the problems. It's very convenient to share the patient information between different operation room. This is applications for the OR, and the last part is applications for the emergency. It's also the similar structures, but here I like only introduce the pre-hospital ambulance solutions, because for in-hospital it's similar to the ICU. For pre-hospitals, sometimes the ambulance is running by hospital itself. So the patient in the ambulance is very critical, and the time for them is also very valuable. So if the doctors can view the patient information before the patient arrives at the hospitals, then it will reduce the rescue times when the patient arrives at hospitals. It can maybe directly go to the operation room doing operations, etc. So for this IT solutions in the ambulance, you can have the defibrillators or maybe patient monitor in ambulance, and then install a VPN client on the ambulance with a 4G network card. Then using this defibrillator and N1 connect to the VPN client. Then this VPN client using 4G network to send the real-time vital sign and also 12-lead ECG information to the hospitals. It can receive by the central station in the ER nurse stations, or the doctors can view by themselves. Especially for the myocardial infarction patient, the door to balloon time is very critical for them. So maybe only several minutes delay for the rescue. They may have the permanent brain damage. So if the doctors can view the situation during the patient in the ambulance, when patient arrives hospital, directly give the treatment, it will highly increase the possibility to saving the lives. And sometimes I know in South Africa, the ambulance is running by the third-party emergency service. For these structures, we also have the solutions. Also similar at the ambulance side, using the defibrillators to connect the VPN client with a 4G network. Then the information transferred to, sometimes the ambulance may serve for different hospitals, to the different hospitals, and also to the EMS management centers. Then the doctor, then the emergency centers will guide the ambulance to which hospital, and then synchronize the patient information to, for example, go to hospital A. They synchronize the patient information directly to hospital A. Then when the ambulance arrives at hospital A, it can directly send the patient to the ER, so to save the time. And this is how the layout look like in the emergency centers. Here you can see the information integrated to the third company software. Here it shows the patient information. On the left, it shows the different ambulance. And you can also transfer the videos. If the ambulance have the camera, it can transfer the videos to the emergency centers. Here, the patient information and also even the position, if the ambulance have the GPS, can same time, can real-time synchronize to the emergency center and to the hospital. This is one case, real case. And here now choose the ambulance 1. And then it checks the patient in ambulance 1. Then choose another ambulance. It can show the real time during the patient in the on the way. So this is solutions for the emergency. So for above, I have already introduced the different structure and solutions for ICU, OR, and the ER. And at the last part, I want to say that for the future healthy care is data driving the management for the hospital healthy care to improve the qualities. because nowadays the people always talking about the data collection and intelligence, and this is the general structure of this. The first step, we need to collect a lot of data. Then we need to make the data visualized. Then using this data, we mining for the useful information, and then using the intelligent technology to apply this. So the data is the future. Also for the hospitals, every day, a lot of patients, a lot of work, a lot of informations to be collected. So if we can use this information in a very intelligent way, it will reduce the cost and improve the operation efficiency for the hospitals. But nowadays, there are a lot of challenges. You see, for the data integration failure or missing or incorrect data, etc. But with this mConnect platform, as I introduced in previous part, it can help to build your own database for the hospitals. And you can using this data to do very useful work. For example, for alarm statistic, to improve the care qualities, you can check what is the top 10 alarm in the ICU, and maybe what is the top 10 alarm in different times. So you can analyze this to see what is to be improved for the whole workflow, or maybe there is a potential risk to be avoided. So this is for the alarm statistic. And for the engineer, for the device management, all the device informations, if you connect to the systems, it can be automatically collected to the systems and statistic. So here you can see it can calculate the devices distributed in different departments, and also the device status, how many devices defect, how many devices in using, and how many devices it need to be maintenance. And also the usage of the devices can be also calculated. For example, in one department, there are a lot of devices, but they are not in use very frequently. They are all sleeping. In another department, they have limited devices, but they need more. So you can using this statistic to optimize the distribution of devices, to move the devices from one department to another department. So without purchase further devices, so you can improve the efficiency of the usage in the hospital. And that's just, yes.
You've spoken for 55 minutes. How long are you still going to be?
This is last, almost the last page.
Okay, we have quite a lot of questions. Thanks.
Okay. So this is two applications, and then the rest is for the reference side. We have a lot of hospitals install our solutions in their hospitals. For example, this Royal Papaworth hospitals in UK, and this hospital opening ceremony, the Queen also attend. So they are using our solutions now. So that's all for the presentations. I already see there are a lot of questions. So
thank you, Danny. That was very informative. I must say, I worked on ICU monitoring systems probably middle 2005, 2006. It's interesting to see how the technology has evolved since then. My colleague Dieter will now be showing you a list of questions we received from our people here. And I think you could just go through the questions one by one and answer them for us. Thank you very much.
Okay. Yes, the first one is the app designed for Android OS Olen. Yes, now in current stage is Olen for Android OS because it's a more open systems. We still not, you cannot still, we have the app in the Apple stores. You can download them, but the functions is a little bit different because the Apple have more strict rules. So it can, if you're using the Apple, if you use the iPhone, so you can also have these apps, but without the alarming. It can only give you, promote the message. There is no alarming. So we have the apps for both OS, but it's a little bit different. So you can also search in the App Store for this one, download it to your cell phones to have a view. It's called the Mobile Wear. if you have the iPhone on hand, you can just search on the App Store, the mobile wear. So another common question, do you have recommended EMR or HIS or can you adapt the interface to any systems? So the second questions, we have some very successful cooperative with the HIS systems providers in Europe and also in Latin America or the US, but in Africa, till now, we still not find a very powerful supply for this EMR and HIS. If that's possible, I can introduce the supplier of the HIS or EMR supplier from the Europe or US, because we already have the successful integration with their systems. So it's more easy to directly use. And if you have some local suppliers for the HIS, of course, we can integrate our system to theirs, because as I mentioned, we are using the HL7 standard protocol, but we need to, how to say, together work out with these local suppliers, because we also have some detail to fix for two different systems, but it's possible, and we have a lot of successful experience. Can we get a copy of the presentation? Yes, of course. I will share the presentations to KISA. Then you can get from the KISA site in South Africa where the system is installed. Okay, so in South Africa now we, as I remember, now we have one hospitals in Bloemfontein, the Imoyamed hospitals. It's a private hospitals. We have our systems installed in this hospital and also with the mobile wears. So the hospital doctors can check the patient information even out of the hospitals. So if you are in Free State or in Bloemfontein, you can maybe visit this hospital to see. And where this data is located is within the hospital must be made when planning and design. So the data is saving in the central station. So it's, for example, if your hospital don't have your own hospital server, you can use a PC, the normal PC in the nurse stations to use as a central stations. The data, you select one PC to save all this data. And if your hospital have your own IT room and with a server, you can install the central station in the server. And also we have the server versions. It can connect more beds and also can save more data. Is the data is saving in the hospital, made available when planning. Yes, you need to make sure the space, the saving space is big enough for the patient data, because every day for the patient monitoring, it's have a huge data. But you can set in the strategy. For example, after half a year, it will delete the information after half a year, or maybe it will pack the patient information in a half a year. So in a smaller size. So and then you just save these hard drivings into the hospitals. Application compatible with all mobile devices. For the compatibility, I'm not sure for all devices. We have tested several devices. For example, if you on the cell phones, we have tested on iPhone and also several mainstream brand of the cell phone. And for the PAD, we also tested several mainstream. I have a list from our R&D. I can share later, but I cannot sure we are compatible for any mobile devices. Please work on the application project. AP for medical device maintained with a group of students from major issue with the application prototype. The scanning barcode feature will work for some devices. This To this during the testing phase. Okay, but for our apps and the devices, till now I didn't receive the similar questions. So I think this won't be a problem. So if you have interest in, maybe we have the branch office in South Africa, and we have all these whole solutions in our branch office. If you have interest, maybe we can together doing the test or demos to check whether this have the compatible problem or not. Okay, what type of maintenance is required on this unit? Tuning and technologies each year. So because this information system is mainly the software, so for the hardware you can use in our PC, or maybe you can purchase a PC from locally. So I think it's not as frequently as the general medical devices. Maybe just 1 year, one time maintenance is enough. But sometimes if the hospital engineer, they don't have very experienced IT background, they may have some problems facing during the settings. Or maybe if they reinstall the PC, or maybe upload the software, it may have the problem to reset the software. But it doesn't matter because we have the local engineering in South Africa. So if there meets any questions, we can directly send our engineers to the hospital to help to doing the maintenance. So at least for some big hospitals, we can doing 2 maintenance per year by our own. So we send our engineers to doing the maintenance. No need any cost from the hospital for the general maintenance. How is the network security maintained? Okay. The last one is very good questions. So if, as you can see, all the patient data is streaming in the central stations. So if anyone have the access to check the patient data, it will have the privacy problems. We have the MLDAP systems to secure these patient data. So for different users, they can only check their own patient. For example, the Dr. A, it only have the right to check the patient in ICU 1. So with his own ID and password, he can only assist this patient data. For another doctors, it have another right and another different patient. And the hospital's manager can manage the different right and the security strategies by themselves. And for the information security during the data transfer, you can see we can using the 4G network to transfer the patient data. If the hospital has the self VPN server and client, this is very safe. So it's no problem for the privacy. But if you using the public IP, if you just send the information to the public network using a public IP, this may have some privacy problems. So that's why we suggest to using the VPN to doing the remote or data transfer. For the in-hospital data security, just as I mentioned, only the right person or the people with the password or their own password, they can assist the certain patient. So there is no any security problems.
Danny, thank you so much for a most informative presentation. We thoroughly enjoyed it. I can see all the positive compliments coming through from all our members. Thank you so much for making the time and for sharing your experience on this wonderful Mindray ICU monitoring systems. We really appreciate and value it, and we look forward to seeing all our members at the next GISA meeting. Okay. Thank you very much.
Thank you.
All the best to you. Bye-bye.